Hey everybody, Mitch with Smedley Plumbing here, and I wanted to go over one of the more common repairs you might come across with electric water heaters. And that can be either an issue of no hot water or an issue where the red reset button underneath this top access panel is constantly tripping on you. So we're going to go over some of the common causes for that and how to determine what is the cause of that. So come along with us and we're going to pop the cover off of this thing and dive into it a little bit. First thing that we're going to do is we're going to pull off the upper access panel and take a look at what's behind there. So let's remove the screws. Some water heaters have a single screw up top to do this. Other water heaters will have two screws. They'll have one on the top and one on the bottom. And then we've got a layer of insulation on here. And typically that layer of insulation is kind of held down with these wires. This insulation is very important to the water heater's operation because it helps keep the temperature sensitive elements that are behind here, the temperature sensitive thermostats. It helps keeps those more in tune with the temperature of the water. So this piece of insulation here doesn't really matter about like keeping the water to temperature. It matters more about keeping the colder room air off of the back of the thermostats. So we're going to peel these wires away. And then one thing that I always do whenever I'm working on these, obviously number one is we want to make sure the unit is de-energized. So we're going to turn the breaker off before we do anything. But to get this insulation out of the way, because it's nice and thick, is I always cut it. Typically it's attached here and you would flip it up and out of the way. Well, then it's a pain in the butt to have to work around. So I always cut this insulation and set it aside. I just get my knife and score it. So that insulation has already been cut out. And again, another reminder, our power is off at the moment. So another thing that we would do is we would remove this, and it even tells you turn off power before servicing unit. So we're gonna pull this out of the way and get this out of here. It hooks onto a little hook up here in the top of this, but you can snap this out of the way and get it completely out. And now we are looking at just the upper thermostat and the upper element of the water heater. For today's work, we're going to be using a digital multimeter, and the unit that I use is a UEI G2 unit. The model number is DL369, and ultimately you can kind of use any multimeter you want, but it needs to be able to do voltage and amperage, and it also needs to be able to measure continuity. So just keep that in mind. One of the first things that you might encounter with one of these units is this red reset button right here is popped out. And what causes that is not, a lot of people get under the wrong impression that that is some form of circuit breaker, and it's not. It has absolutely nothing to do with the amount of load going through the electrical system. What this red button is there is a temperature sensor on the back side of the thermostat right here. And it's basically a piece of metal. And if that metal gets too hot back in here, it will pop the other way and pop that reset button out. So anytime you come up to a heater where that reset button has popped out, that means that this area of the tank has gotten way too hot. And so that reset button popped out as a safety feature. So the moment you walk up to a water heater and you recognize that reset button has popped out, you know one thing, that even though that water heater may be cold today, at one moment it got way too hot and that button tripped. The next thing that you're going to want to encounter is, again, you're going to take your digital multimeter and you're going to set it in voltage, and you're going to take your leads on the two incoming wires on the top of the unit, and you're going to verify that we have no power going to the unit right now. You can use your multimeter as a safety device in many cases like that. Then in a controlled setting, and you want to be very okay and very safe when you're doing this, you're going to want to go turn the breaker back on after you've reset this button. And now we're going to walk you through a couple of steps that you'll be able to do to diagnose what caused the overheating scenario that caused this button to turn on. The first step you're going to do is when you turn the unit on, the first step in the sequence of operation for this unit is it's going to fire up the top element first. That's right here. As it fires that element up and the top of the tank gets to temperature, then this thermostat stops sending power to the top element and it sends power to the bottom element. And then when the bottom element is satisfied, the bottom element will kind of revert that power back up to the top. And actually the way that it happens, the bottom element becomes satisfied. The top, as long as it is satisfied, it continues to send power to the bottom element. And then if there's ever a condition where cold water is just running out of the tank and that line between cold water and hot water increases, this thermostat cools back off and this thermostat pulls power away from the bottom element and re-energizes the top element. So the first element that should come on in the sequence of operation is this top element. The way to understand if this top element is receiving power, again, you're going to use your multimeter, you're going to set it to voltage AC, and then you're going to put your leads one on each of one of these screws. And in most residential applications, you should be getting 240 volts. If you get 240 volts right here, this element is being energized and calling for heat. If you get 120 volts right here, then chances are this element is not calling for heat. So once you see that you have 240 volts right here, the very next step is you take your multimeter and you check amperage with it. So our multimeter has this amp clamp on the top. We would simply open the amp clamp up and run it around each wire. Okay, so we're going to check amperage on this wire, and then we're going to pull this wire over, and again, we're being very safe because the power's back on, and we're going to check amperage on this wire. So most residential water heaters are going to have a 4,500 watt element. And if we take 4,500 watts and we divide that by the 240 volts that are coming in and as power, then we are left with 18.75. So volts times amps equals watts. We have 240 volts coming in. We have 18.75 amps running through these wires. That creates 4,500 watts. So when we have a 4,500 watt element and we have 240 volts coming in, we should see 18.75 amps on each one of these wires. When we check these wires and we are seeing a reading significantly different than what the math would indicate, that tells us that we have a problem with this element. There's a lot of other ways to test these elements. You can take the wires off of them and you can measure the resistance of the elements, which is an ohms reading. You can also set your meter to continuity, and when a meter is set in continuity, it means if the leads touch each other, then if these two leads were to touch each other, it will beep. I can simulate that right now. So right now I've got my meter set in continuity, and then if I touch these, you're going to hear it beep. Okay, so if I were to touch these two on these screws with the wires removed, you would also hear it beep. And I can simulate that for you right now too. Let's pull these wires off real fast. And again, we're being very careful because this unit is energized. Okay, so our meter is set to continuity. If I touch these two together, it beeps. So now, if I touch these two on these two screws, it beeps. This tells me my upper element is good If you were to simulate that exact same exercise and it did not beep, that tells you your upper element has completely failed. And that would be the first element that I would recommend replacing. The same process works for the lower element. You remove the wires to make sure there's no energy going to the unit, and then you would check its continuity. Just like that. Now we're going to tuck these wires back under these screws. And again, we're being very careful because there's power to the unit. We tuck these wires back under these screws and the unit is back into a heating condition. This unit, or this element, is drawing 240 volts. It's a 4,500 watt element. And when we check amperage around each one of these wires, we are getting 18.75 amps. Another way that an element can fail is it can partially fail. And if an element partially fails, then you may still pass the continuity test. So that's where the amperage test comes in. And I usually just go straight to the amperage test. But let's say we check this wire and we get 18.75 amps or anywhere close. Let's say it's maybe 18.4 or something like that. That's still close enough. So we check this one and we get, somewhere in the middle 18s on amperage. And then we come over here and check this wire and we only get 16 amps. Well, that would tell us that this leg of the element has a partial failure in it and it's not able to draw its rated amperage. So that would tell us that even though this element passes an ohms test or a continuity test, it's failing the amperage test, and this element would need to be the one to be replaced. We're going to shift our focus to the lower element. Now remember, the lower element is only going to get power once the upper thermostat is satisfied and happy. When the upper thermostat or the upper part of the tank has reached its set temperature, it flips power down to this lower thermostat and lower element. So the upper thermostat is satisfied and happy, the upper part of the tank is at the right temperature. So now we're energizing down here. We do the exact same simple test. We take our multimeter and we take our two leads and we put them on these two screws. We have our multimeter set to voltage, and we're checking on these two screws right here and we're looking for 240 volts. If we don't get 240 volts, let's say we only get 120 volts, that means that this element is not calling for heat. So one thing that might be happening is maybe it doesn't need the heat. So maybe the entire tank is at the right temperature, and that's fine. One of the things that we can do is we can take a screwdriver and change the temperature of our thermostat and actually crank the temp up momentarily to make it call for heat. And once we turn that temperature up, now this lower element will call for heat, and we can check again. When we check again, now we should be getting 240 volts, so that's great. That tells us that we've got voltage going to the element. Now, we need to perform the same test again, okay? We can loosen these screws and remove the wires and check continuity of the element. I prefer the amperage test over a continuity test. So, on this case here, we've got to dig a little bit for this wire because it kind of gets tucked underneath and behind that insulation. But again, we're going to do the same thing. We're going to take our amp clamp and we're going to run it around both of these wires. We're going to use the exact same math again. This is again another 4,500 watt element, and it'll tell you right on the side of the element where the wattage is. So it tells me it's 4,500 watts, and we know we have 240 volts because we just checked that. So if you're wondering what amperage you should be looking for, we'll go over that again here. The element is 4,500 watts. We checked the voltage, and the voltage was 240. So you take 4,500 watts, you divide that by 240, and it gives you the answer to that is 18.75. That's the amperage. So when we check our amp clamp, we're looking for 18.75. Same rules apply as the upper element. If we're getting 18 on one leg and a dramatically lower number on a different leg, then chances are that is the element that needs to be replaced. We can cover in a different video, we can cover how to physically replace all of these pieces, but this video here is more just to how to diagnose what's going on. A real quick high-level overview of doing all of that though. Elements aren't overly expensive, and so by the time you drain your tank down to replace one of the elements, you may as well drain it all the way down and just go ahead and replace both of the elements. That's usually a really good practice. A lot of times you'll find the lower element has failed first because it does a little bit more of the heating than the upper element, and there's a little bit more sediment down on the bottom. So if you have to drain the tank all the way down to here to replace the lower element, you may as well go ahead and replace the upper element at the same time. Another thing to consider too is thermostats are not overly expensive either. And a lot of times you can get them in a kit to where you get 2 new elements and 2 new thermostats. So even though we've done this video to show you how to diagnose which individual component is failing, sometimes a complete rebuild is not a bad idea. There's not too much to electric water heaters. You've got a tank, you've got a temperature pressure relief valve, which is right here, and then you've got 2 thermostats and 2 elements. So if your relief valve is not dripping and you're just not heating on water, well then the only things that can be wrong are either one of the elements are bad or either one of the thermostats are bad. A total rebuild is usually a fairly economical decision, and it'll give you all new parts and the longest of longevity when it comes to moving forward with that water heater. Now that we've checked everything out and we know we're in good operation, let's go ahead and put everything back together. So our 2 plastic covers that we have, one is larger than the other. The larger one goes on top because the upper reset button has the upper thermostat has the reset button built into it. So this one snaps onto the bottom. And it's not a bad idea to de-energize the unit while you're putting these on, because if your finger slips or anything while you're doing this, you might end up touching something that you don't want to touch. So that is snapped back in place. And then we take our foam that we've cut out of here, and this particular model has a slot in the foam for the wires to come through. So we take our foam and we put it back in place. Again, this foam is very important to make sure that, like, if we were to leave this cover off and that foam completely off, this water heater would overheat very, very quickly. The reason why is because most of that thermostat is exposed to the cold room air. Our room might be 70 or 80 degrees, and this water heater is trying to make it 120 degrees. Well, if we expose this thermostat to the room air, the thermostat thinks it's sitting in an 80-degree environment, and so it's going to keep heating the water and keep heating the water and keep heating the water because the thermostat never warms up. So this piece of foam is incredibly important to making sure that your thermostats work properly. We're going to tuck this back in here, just like that. And then we take our cover and we mount it right back into position. Now let's do the upper one. Okay, so we've got the lower one buttoned all back up. Let's do the upper one. Same rules apply. Again, not a bad idea to have the unit de-energized at this moment, because as we're snapping all of this stuff on, we might accidentally touch something. First thing we're going to do is put our cover back on. These covers, they've got 4 alignment rods on the back of it, and then it's got a snap hook over here. So these alignment rods will slide down the side channels of the unit, and then the top just kind of snaps on. It just kind of sits over it, just like that. Next piece to go in is, again, our really important piece of foam. So we take our foam and pack it in there, and then we fold these wires back over it to kind of help hold the foam in place. And then last but not least, we have our nice decorative cover. And our unit is all back together. So right now we could go turn the breaker back on, re-energize the unit, and it'll be back in service. So, key takeaways from today's video. Remember your math. Wattage divided by voltage equals amperage. So, your elements will tell you what wattage they are. You're checking the voltage to verify exactly what voltage you're getting. And then the next thing you want to do is do that math to learn how many amps you should be looking for. You check one wire at a time, you look for those amps, and that will lead you into the right direction as to which element is causing you the problem.